All right, for our next example, for another hypothesis test to walk through to make sure we're good, we're going to use the data from problem number 22A from the back, page 369. Again, the question wraps up a lot more details related to another question. We're not going to worry about all that. You can read that and take care of the other elements if you wish on your own. We're just going to do the hypothesis test itself. So this particular problem for 22, almost all the prep work has already been done. We have our little n's, we have our capital N's, we have our t's, we have our g's, we have the summation of squared raw scores, we have sums of squares, we have everything but what is not explicitly stated, a k of 3. That's the only thing not in our prep work. So there really isn't much in the way of prep work here. All the calculations are already taken care of for us. So our k equals 3. Step 1. Again, there's only one way of writing this and getting any points for it. It's English. The only derivation is, again, you can switch that mu out for the word treated population mean. Again, no more capital M's, guys. There's either got to be a mu or the English equivalent. And same thing down here. Treated population mean 1 equals 2 equals 3. This says at least one of the groups will be different. This says, no, they'll all be the same as each other. So nothing new to talk about there. Step 2, again, we know we can set it up, but we don't have the values yet. So on our paper, we want to note that the alpha level is 0.05. We know we're going to need our degrees of freedom between treatments, which we do not yet have. Our degrees of freedom within treatments, which we do not yet have. And then using that, we can look up our critical F and make our little graphic to help us find our answers. So all we can do in this step is just write those things down and wait till we're ready to go on them. So let's go ahead and start cruising through step 3. So again, I can only work the table in little pieces at a time here, as we already know. There's not really a whole lot I can do about that. But start with our sums of squares between treatments column. So our sums of squares between treatments, we know that that's the summation of all the squared t's divided by sample sizes minus g squared over the total number of scores. In this case, again, all the t's have been given to us. So the first treatment total is 10, and there are 10 people in the sample. Second treatment total is 50 with 10 folks. Third treatment total is 60, also with 10 folks. And G is 120. And the total number of scores in the study, of course, is 30. Now, just as a reminder, these numbers are all the same in this problem, just like the last one we did, but they don't have to be. So just be careful that you're not taking it for granted that they're all the same sizes. Make sure you look carefully at the data. There are problems with different sample sizes. So when you compute all of that, again, I recommend you pause it and get your calculator running. And what you should come up with when you're done with all of that is 140 points. Now we can get our sums of squares within treatments. So we know that's simply the summation of each group's sums of squares. The first group was 81. The second group is 90. And the third group is 99. 81 plus 90 plus 99 gives us a total of 270 points. So again, what we want to do is pause, look at these numbers, 140 and 270. The first piece and the second piece, add them together, it should equal the total. So 140 plus 270 is 410. So when we compute that, we need to see 410 or we have some type of mistake. So our sums of squares for the total study is the summation of raw scores squared minus, again, our g squared over total number of scores. Well, the summation of all the scores in the study squared is 890. Again, g is 120. And the total number of scores in the study is 30. So square your 120, divide it by 30, then subtract it out of 890, and you get the number we were looking for, which is 410. First row of calculations done. So let's carry on to our degrees of freedom. Our degrees of freedom between treatments is k minus 1, and k we know is 3. Our degrees of freedom within treatments, simply sum up the degrees of freedom for each group. Well, each group has 10 people in it. 10 minus 1 is 9, so we need 9 plus 9 plus 9. So 9 plus 9 plus 9 is 27. And again, we want to take a pause. Part 1, 2 points. Part 2, 27 points. The total had better work out to be 29 points, or we've missed something. So degrees of freedom total is capital N minus 1, which is 30 minus 1, which is, of course, 29, which is exactly what it should be. So I know I'm probably shooting through this a little quickly, but I know you're watching this on video, so you can pause and rewind and replay all the stuff you need to do to pace it for yourself. So 3 calculations left. Calculate for our mean of squares between treatments. That's your sums of squares divided by degrees of freedom. Our sums of squares, we said, was 140. Our degrees of freedom was 2. So our mean of squares, or variance between treatments, is 70 points. Again, our variance, or mean of squares within treatments, is sums of squares divided by degrees of freedom for both within treatments values. So we've got a 270 divided by 27. 10. So our variance within treatments, our error term, is worth 10 points. So that just leaves us for our F ratio. So our F ratio is going to be 70 divided by 10. Our F is your mean squares between treatments divided by mean squares within treatments, 70 over 10 equals 7. So because it's a statistic value, we've got to write that out to 2 places. So to the right of that box, I'm not going to take the time to erase for it, but to the right of that box, what we would be writing here is an F of 2 and 27 equals 7.00. Start writing like it was APA. We don't know the decision yet. So again, that'd be right over here, right off to the side. I'm just trying to not break this into too many little pieces if I can help it. So now we go back to step 2. And in step 2, we saw now that we've got our degrees of freedom values. Our alpha level was 0.05. Our degrees of freedom between treatments was 2. Our degrees of freedom within treatments was 27. Yeah, 27. So again, we need our table. We go over to 2, and we need to go down to 27. Well, this page ends at 18, so we got to turn to the next page. 2 and 27. Our choices are 3.35 or 4.49. We're doing the 0.05 level, so we want the light face option, 3.35. Our F statistic was 7.00, so that's going to be over here. So we are now in the shaded region, which means that for step 4, our decision is going to be to reject the null hypothesis. So the decision is to reject the null hypothesis, and if we needed to report that in APA, an F of 2 and 27 equals 7.00, semicolon P less than 0.05. So we're going to pick up. We've got more work to do now, actually. I know you're thinking, oh God, no. But yes, there's more work to do. So in the next video clip, I'll explain why this problem requires more work than the last one we